In section 113, we're still working on solving systems of linear equations, but now we get to have three variables. If we have three variables, we're going to need three equations, like our 2x2 systems in the previous section. Now it's 3x3 systems. You need three equations to solve a system with three variables. Okay, let's jump into this one. We are working for a company that sells pewter lamps. We're going to make three different kinds of oil lamps. We got small, large, and deluxe. And we've determined for our needs that we need a total of 260 hours for spinning, 170 for polishing, and 120 for assembly. So we're trying to figure out how many how many lamps we're going to be able to make if those are the man hours that we're able to accommodate this week. So we're going to use X, Y, and Z to represent each of the lamps. So our small lamps be X's, our large lamps be Y's, and our limited edition lamps be Z's. Okay, so the information is organized here. If I want to spin, a small basic lamp takes 1 hour, a large one takes 3 hours, a limited edition one or deluxe one takes 4 hours. I'm going to polish 1 hour, 2 hours, and 2 hours. I'm going to assemble it 1 hour, 1 hour, and 2 hours. So we're going to make three equations here. We're going to make an equation for spinning, for polishing, and for assembly. So this is actually a really nice chart set up here to help us with this. If we're going to spin, then we know that it takes 1 hour for a basic lamp. So 1 hour per basic lamp, 1 times X would be the total hours for the basics. Plus it takes 3 hours for the large lamps. The small was 1 hour, the large were 3. Plus it takes 4 hours for the limited edition. So 4 hours for each of the Z lamps we have. Now we have a total of 260 hours for spinning. So if we add up all of those, 1x plus 3y plus 4z, it should equal to 260. Same thing for the next one, 1x for polishing plus 2y for polishing plus 2z for polishing is going to take a total of 170 hours for polishing. And last, 1 hour for X plus 1 hour for Y plus 2 hours for Z is going to be that 120 hours for assembly. So we have three equations with three variables, X, Y, and Z, and we're going to solve this system. When we had 2x2 systems, the two variables and two equations, we were able to use two different by hand techniques. We had our substitution technique and our addition technique. When we have three, we really have to stick with the addition technique because it gets really messy to try the substitution technique, and it does not always work. It can cause some problems with what to do. So we're not going to do that. We don't want any problems here, right? So we're going to use the addition method. And we're going to use the addition method. It does say use substitution or addition, but we're going to maybe use substitution later. We're going to start with addition, and I would probably just continue with it. We have to get rid of the first variable, and we're going to get rid of, let's see, if I'm looking at my X's, my Y's, or my Z's, X's, they're actually already all ones. Y's, I could do like 2 and 3 or make a 6, or I could do 1 and 3 and 2 and 1. I could use like 2s or 3s or 6s depending on how I blended them, right? So if I did these two, it'd be 2s. If I did first and last, it'd be 3s. If I did those two, it'd be 6s. And the Z's, it would be 2s if I'm using those two, or 4s if I'm using either one of those pair. So just broadly, we're going to think about all those possibilities, and then we're going to pick ones because there's no number change here because it's 1 off for all of those. So that's the obvious choice. If these were different numbers like 5 and 7 and 1, then I would pick this as my next best choice because I got 2 that are the same and then just a quick change to get those into 4s if I need them. So first choice, though, all those ones. Beautiful. Okay. Now, I'm going to pick just 2 equations to work with first. Doesn't matter which 2, but just 2. So I'm going to pick equation 1 and 2 to get rid of one of the variables, to get rid of X first. I can't do all 3 at the same time. I'm going to do just 2 of them. All right. And the variable I'm going to get rid of is x. Now, if I added them right now, there would be 2x. 1x plus 1x is 2x. So I have to make sure they're opposites. So I just have to pick one of them to multiply by a negative one. I'm going to pick the second equation. The only reason for that is that I notice that this number is smaller in the second equation. So if I make that negative, then I'm going to have a positive when I finish the subtraction. So I like positives. So I'm going to choose to do that. So writing down my equation for the top, 1x plus 3y plus 4z equals 260. And then distributing that negative to the second equation, negative 1x minus 2y minus 2z equals negative 170. And we're going to add those two equations up, eliminating the x variable. 1 minus 1 is 0. 3y minus 2y is 1y. 4z minus 2z is 2z. And 260 minus 170 is, we can assist in the calculation if necessary. We can find out that 260 minus 170 is 90. So we're going to put our 90 here. Okay, not done. I don't know what y or z is, but now I'm down to just two variables. So I need to do this again. I need to take a different pair of two equations, and I have to get rid of the same variable. So I'm not going to reanalyze these. I must get rid of the same variable with two different equations. So I can choose equation, I did 1 and 2 already, so I could choose equation 2 and 3, or I could choose equations 1 and 3. So I'm just going to pick that arbitrarily. I'm going to choose equations 1 and 3, and we're going to get rid of x again. I'm going to use a negative 1 on this equation. Again, I have a positive 1 and a negative 1. And again, this one had the smaller, so I figure I'll get another positive if I make this one 20 negative. So that's my strategy. Rewriting the 1x plus 3y plus 4z equals 260. And then the negative 1x minus 1y minus 2z equals negative 120. So that gives the x's add to 0. 3y minus 1y is 2y plus 2z, 4 minus 2 is 2, equals 140 if I do 260 minus 120. Okay, so I have now two equations that are in two variables. So if I work those two together, that's a 2 by 2 system like we worked on in section 111 and 112. So I could use any of those methods. I could use substitution or addition, whatever I want to get rid of one of my variables. I'm on a roll with the addition methods, so I'm going to keep it up. And I'm going to notice that my y's, 1 and 2, I could make them both 2's, or my z's are already both 2's. So since they're already both 2's, let's get rid of z. All right. Okay, so I'm going to get rid of z. And that means that I want a positive and a negative. One of them needs to become negative. How about I make this number, since it's smaller, negative? So we're going to multiply these all by a negative 1 as we write it down here. So the top one becomes negative 1y minus 2z equals negative 90. And the other one was 2y plus 2z equals 140. We're going to add those up. Negative 2z and 2z adds to 0. Negative 1y and 2y adds to 1y equals negative 90 plus 140 is 50. Now, it asks me to solve the 2 by 2 system, and a 2 by 2 system is not solved until you know both variables. So I'm going to double check on my next page if they don't give me space to do it there. Nope, it doesn't, because it wants me to solve the system. So I need to get the other variable. I only have half of the solution to the 2 by 2. One of them is y equals 50. So into one of these equations, I'm going to plug in y equals 50. I'm going for the one with the smaller numbers because I can. I'm going to pick 1y is 50 plus 2z equals 90. So if I subtract this 50 from both sides, 2z is 40, and then divide by 2, so z is 20. So my 2 by 2 system is solved once I know what both y and z are. I do still need to know x. To be able to find x, I'm going to take the y and z values and I'm going to plug them into one of these, my choice, for y and for z. So if I examine these, I like the one with the smallest coefficients, so I'm going to take the bottom one, and there's space to do that on the next page. So I got to remember this equation for a second. 1x plus 1y plus 2z equals 120. Too high, sorry, I'm just writing the equation. Equals my 120. And we had y was 50 and z is 20. So if I plug those in, 1x is just x, plus 1y, that's 50, plus 2 times 20 equals 120. So x plus 2 times 20 is 40, 50 plus 40 is 90, equals our 120, and we're going to subtract 90 from both sides. So that gives us x equals 30. Okay, so now I have all three of my solutions. X equals 30, y equals 50, z equals 20. So we can draw our conclusions that we need to make 30 small lamps, 50 X was large lamps, and 20 deluxe lamps. Oops, I went 2 pages. Those were our, or limited edition, but they did use the word deluxe up here for those lamps. So we have our 30 small, 50 large, 20 deluxe. If this was a non-contextual, not story problem answer, we could answer this in an ordered triple. So ordered pairs are x comma y, ordered triples are x comma y comma z. So the solution could be presented as 30 comma 50 comma 20 in an ordered triple. But since it's in context, we want to give the sentence to explain what each of those means in context. All right, number 9. Why is it not possible to solve this system on the graphing calculator? Well, when we graph, we have 2 directions in which we can graph x and y. There's nowhere to put the z. That's why, okay? Because our graphs are 2-dimensional, they're not 3-dimensional. You can make 3D graphs, but they're a lot harder to do, and they require expensive software. So can't do it with our free Desmos, and we don't want to. Even if we were able to, they're very difficult to look at because you're limited to a 2D plane to look at them. So it's not something that is done. So we got to do it by hand. Here we get to try again. One more. All right, here is a system. I want to solve this system. Oh, there is a note up here. Again, these are linear equations, even though they can't be graphed as single lines, because like my pen is a line, and it can be like heading off the screen. So you can take a line and you can have your line just displayed in space instead of being flat or diagonal. It can be going up as well. And so it's still a line, but it's now in 3 dimensions. That's what we're doing here in this situation with these 3 variables, is we lift our lines off the page a little bit and give them a vector into space. Kind of cool. All right, so we got a system of here. I want to get rid of a variable. If you're not sure where to start, follow these steps. Okay, so I'm going to pretend I don't see these steps, and I'm going to look at my variables, x, y, and z. And I'm like, okay, I could do some 2s and 3s and 6s. I could do some 2s and 3s and 6s. Or look at those beautiful 1s. I could do z's without having to worry about 2s and 3s and 6s being what these would have to multiply. If I did these two together, it'd make a 6, or these two with a 2 and those two a 3. I like 1s. 1s are nice. 1s are small. We're going to go with 1s. So we're getting rid of z. And again, that's their hint. They want us to get rid of z. But getting rid of z. Okay, so I get to choose. I could do equation 1, equation 2, equation 1, equation 3, or equation 2 and 3. This one's positive, so I'm going to work it with the next one, which is negative, because they're going to add up. So that's my first choice. Okay, so x minus 2y plus z equals -5, and 2x plus y minus z equals 6. X plus 2x is 3x, -2y plus y is -1y, z plus negative c is 0, and -5 plus 6 is 1. Done with that part of it. I got an equation in 2 variables now. All right, so choices, again, I could do equation 1 with equation 3 or equation 2 with equation 3. Since I already have opposite signs with 1 and 3, that would be my choice. 2 and 3 I could do, but I would need to multiply one of the equations by a negative so that they were going to have opposite coefficients. And currently with 1 and 3, I don't need to do that, so why add an extra step? Let's not. Let's just do the top equation and the bottom equation, since they already have opposite signs on their z, and they have same value, opposite signs. So when I add these up, the z's are going to cancel again. X plus 3x is 4x, -2y plus 3y is 1, y, -5 plus 11 is 6. All right, and continuing on, now we have 2 variables and 2 equations. So let's do these together. Look at those y's. Don't they look amazing? Our y's are already coefficient 1, already opposite sign. So let's add them up right now. I could do substitution. I could solve for this y. It's just going to make extra steps. So I don't want to make extra steps. I want to just do what's already ready. Okay. Add them up. The y's are going to add to 0. So I've got 7x equals 7. And if I divide both sides by 7, I get x equals 1. That's half of the solution to the 2 by 2. The solution to the 2 by 2 does need both the x and the y. When you solve a 2 by 2, you get both variables. Okay, so I'm going to put this x equals 7 in the top one. So